In this video, we're going to talk about a quantitative property of solutions, that is their concentration. Concentration is abbreviated lowercase c and is equal to the amount of a solute mixed into a given amount of either solvent or total amount of solution. Okay, and just to remind you, in a mixture, and in particular in a homogeneous mixture of a substance, okay, which is a solution. So if you have a homogeneous mixture of substances or a solution, then the solvent is the substance which is present in greater amount. So for instance, if you have a beaker of water, 500 milliliters, and you want to make a solution of water and ethanol, and happen to have 10 milliliters of ethanol, which you then mix into the water, okay, and forms a homogeneous solution. In other words, it's evenly mixed throughout the whole solution. Then in this case, the solvent is going to be the water, because it is in the greater amount, 500 milliliters. And the solute is the ethanol, which is only present in 10 milliliters. And then, of course, the solution is the water and ethanol mixed together. In this case, its total amount will be approximately 510 milliliters. So you can see why, whether you define your concentration unit in amount of solute over amount of solvent, or amount of solute over amount of total solution, makes a difference, because the solution is always slightly greater in amount than the solute alone. Okay, so we're going to now talk about how we express the amounts of solute and the solvent or solution. In other words, how do we define those quantities? Well, you can use lots of different things. For instance, concentration can be in mass of solute over mass of solvent or mass of solution. You can express the quantities in volume. So if you have two liquids, that might be very convenient to talk about the total the volume of solute over the total volume of solution. You can have mass of solute over mass of solution or mass of solvent. And most commonly for us, we are going to see moles, or quantity in moles of a solute over the volume of the solution. And in particular, we'll be looking at a concentration unit which is called molarity. And we'll be using this concentration, chemists use this concentration unit very often. A molarity, which is abbreviated with uppercase M, is defined as the moles of a solute per liter of solution. Okay, so if I divide the moles of a solute by the total liters of solution, that will give me a concentration of the solution in moles per liter. It's important that you note that this is liters of solution, not solvent. Okay, so often problems will talk about the final volume of the total solution, and that's what you want to use when you calculate concentration units in molarity. We'll do a quick practice problem with this unit. So we're going to calculate the concentration in molarity of a salt solution. So calculate the concentration of a salt solution prepared by dissolving 35 milligrams of sodium chloride into enough water so that the total volume of the solution is 75 milliliters. So in other words, the 35 milligrams of sodium chloride plus water will end up with a final volume of solution of 75 milliliters. In order to start this problem, let's start taking some of the key information out of the word problem and organize it so it's a little bit easier to see and make a plan for how we're going to solve the problem. In this case, we're using units in molarity. I like to, it's already written above for us, but I'm going to write it again as if I was starting without that equation above. So the molarity is moles per liter. I usually write that out. Moles solute over liters of solution. So I have that defined. And the units, seeing the units will often help you in devising your plan for how you're going to solve the problem. We also have the solute, sodium chloride, 35 milligrams. That seems important, so let's write that out. Our solute, sodium chloride, and we have 35 milligrams of that. And then let's also take out the amount of solution and write it. Solution is water plus the salt, and we have 75 milliliters. Okay. So this looks like the most important information. I'm already starting to think about the fact that I have been given a mass amount, 35 milligrams of the solute, but in my concentration, I need moles. So in order to do this problem, I'm going to have to somehow figure out how to determine how many moles are in that 35 milligrams of salt. Well, we know that we can convert from a mass of a substance to moles of a substance, like sodium chloride, using the molar mass, right? Because that is in units of grams per mole. So I can convert from a mass of sodium chloride in grams to moles of sodium chloride using molar mass. But I've been given milligrams, but of course I'm thinking now that I can go from milligrams to grams because I know that there are 1,000 milligrams per gram. And so now I have a two-step process for calculating the moles of NaCl in the milligrams of sodium chloride that were of NaCl that was given. Okay, once I have that, I'll have half of the problem done. And of course I was given 75 milliliters, so volume quantity of my total solution, but it's 75 milliliters, not liters. But of course, milliliters can be converted to liters using the relationship there are 1,000 milliliters per liter. And there we go. So now I have a way to get the moles that I need and the volume that I need in the appropriate units. And let's go ahead and work that through. Moles of NaCl is going to be equal to, we're going to start with our 35 milligrams, and we know from our plan that we're going to use the unit conversion. One gram per 1,000 milligrams. So now we're at grams of sodium chloride. We have to get to moles. For that we need the molar mass, as we've shown before, so we'll have to calculate the molar mass. It happens that sodium has a molar mass of 22.99 grams per mole, and chlorine 35.45 grams per mole. So just getting those off of a periodic table. Adding that up, we find that sodium chloride's molar mass is 58.44 grams per mole. And so now we can use that in the equation. Notice that we're going to have it inverted, 1 mole per 58.44 grams, so that our units properly cancel out, grams and milligrams. That leaves us with units of moles, which is what we want. Taking that through, we get 6 times 10 to the minus 4th moles of sodium chloride. So there we go. So that's just about halfway done. Now the volume of solution. From our plan, we see we just have a one-step conversion. We start with our 75 milliliters times 1 liter per 1,000 milliliters, and that turns out to be, after we cancel units, 0.075 liters. Okay, so now it's a simple matter of substituting into our definition for molarity, which is moles of solute over liters of solution. We have both those quantities. So concentration and molarity for sodium chloride is equal to 6 times 10 to the minus 4th moles divided by 0.075 liters, and that is 0.0080, or 8 times 10 to the minus 3 moles per liter, or 8.0 times 10 to the minus 3 molarity.